money, heat, and climate change, modeling using exponential functions. The student works 1 and 2. All right, let's take a look at the next page. Getting started, the elephants in the room. The two elephant populations over time are shown, each with a different small area in Africa. 1. Estimate an exponential function for each population change over time. Okay, let's go ahead and do that. So we're going to go to Desmos, add the table. Now you don't see the point, so we need to adjust our window. So we're going to go from 0 to 10 and 0 to, let's go 4,000. We can zoom out just a hair. There we go. To do the exponential regression, we're going to do y1, shift squiggly, a, parentheses, b, to the x1. And then there's our equation. Let's round it 2 decimal places. So then that's all right, so there's our first equation. All right, now let's take a look at population B. Now you're going to need to convert the graph to a table. So our years are going to be 0, 1, 2, 3, and then at 1 it's 80, 2 it's 60, 3 is at, let's approximate 58. Okay, so let's go ahead and find that equation. So I'm actually going to go to a fresh Desmos screen. Table. All right, and we don't see the point, so I'm going to go here. Let's, for the x-axis, go 0 to 5. Oh, 5, and then y, let's go 0 to 200. All right, we see our points. Now, for regression, y1, shift squiggly. All right, let's round 2 decimal places. All right, there's our equation for population B. All right, use the function and the features of the situation to describe the change in population over time. Population increasing at a rate of population B is decreasing at a rate of all right. Let's take a look at the next page. Activity 5.1, adding functions. Autumn has 2 different methods of saving her money. Analyze her situation using functions. 1. Autumn received a graduation gift of $1,000 from her wealthy aunt. She placed this money in a savings account with a 4% interest rate, compounded annually. A. Write a function f of x to model this situation. Define the variables. X is the number of years, and f of x is Autumn's savings in dollars. So her equation is 1,000, parentheses, 1.04 to the x. B. What will be the balance in Autumn's account after 5 years, 10 years, and 15 years? Okay, let's go ahead and calculate that. So let's go to Desmos. Now in this case, we just want scientific calculator. So oh, and you want to look for that minor mistakes. All right. So 5 years is $1,216.65. 10 years is $1,480.24. And 15 years would be $1,800.94. C, estimate when Autumn will have $1,600 in her account. All right, so to do that, we're going to need to go to Desmos again. Let's go to graphing. So first we want to graph our equation. And then we want to graph y equals 1,600. Now we're going to need to zoom out. Quite a bit to get to 1,600. And then you want to zoom back in to the point of intersection. Now be careful because you don't want the y-intercept, you want the point of intersection. So you want that point right there. So rounding that to a whole number, let's say 12 years. So Autumn will have $1,600 in her account in 12 years. 2. Autumn had also saved $500 that she keeps in a safe at home. She never touches it nor adds to it. Write a function g of x to model the situation. X is the number of years, and g of x is Autumn's savings account in dollars. G of x equals 500. In 5 years, she'll have $500 in the safe. In 10 years, she'll have $500 in the safe. And in 15 years, she'll have $500 in the safe. See, when will Autumn have $1,600 in the safe? Autumn will never have $1,600 in the safe. 3. Autumn's total savings account can be represented as f of x plus g of x. Write a function h of x to represent this sum and predict what the graph of h of x will look like. So h of x is going to be 1,000 times 1.054 to the x plus 500. The graph will be an increasing exponential function with a y-intercept at 0, 1,500 and an asymptote at y equals 500. All right, let's take a look at the next page. All right, let's go ahead and graph f of x, g of x, and h of x. So we're going to go to Desmos. Let's remove these. I want to press the home screen, and I want to adjust the window to match what's on the paper. So we're going to go from 0 to 14 and 0 to 3,000. Okay, now we have that. We can graph All right, so first off, we'll have the horizontal line at 500. So these are counting by 200s. So 200, 400, 600. So 500 is right there. Okay, let's take a look at here. We have a point at 1,000. And we need to find probably one more point. 5, 12, 16. That may be okay, but let's see if we can find. That's close enough to 1,600. Okay, so 12, 1,600. So 0, 1,000, and 12, 1,600. So that's 1,200, 1,400. This is 1,600. Okay, so 12, 1,600 is right here. That is all right, let's take a look at the last graph. So that's 0, 1,500. And let's see if we can find a good point. 1980 is very close to 2000. That might have to be our best point. Yep. So 0, 1,500 is right here. 10, 1980 is close enough to here. Okay, go ahead and finish up your graph. I go ahead and mark out 5, 6. How does the graph of h of x relate to the graph of f(x) and g of x? The graph of h of x is a graph of f(x) with every y value increased by 500. The exponential function h of x can be written in the form of h of x equals a times b to the x minus c plus d. Let's take a look at the next page. All right. Activity 5.2, modeling a decreasing exponential function. Caroline loves drinking green tea. One morning after making herself a cup of hot tea, she sat in her kitchen to enjoy it. The table shows the temperature of a cup of Caroline's tea over time. 1. Model the situation. Create a scatter plot in Desmos. Okay, so let's go ahead and do that. So we're going to add a table. All right, now we don't see the points when you adjust our window. So let's go from 0 to 50. And let's go from 0 to, looks like 200 is probably going to be big enough. Okay, zoom out just a hair. There's your points. Now it says, use Desmos to write an exponential regression equation, defining the variables, identify the correlation coefficient. X equals the time in minutes, and f of x equals the temperature of the tea in Fahrenheit. So our equation then is y1 go ahead and round to 2 decimal places. Okay, so our equation is f of x equals 174.86, parentheses 0.99 to the x. And our correlation coefficient r is equal to, in this case, r squared is equal to 0.97. Sketch the function on the same graph as the scatterplot and Desmos, which we did. Let's take a look at the next page. 2. State the domain and range of the function you sketched of this problem situation. Domain is 0 minutes to 50 minutes. Range is 101 degrees Fahrenheit to 180 degrees Fahrenheit. 3. Use a temperature to predict the temperature of the Carolina tea after an hour. All right, so let's go ahead and do that. And let's fix this. This is missing the 2 decimal places. Should actually be 174.86. All right, and I believe we have to fix that here as well. Let's go ahead and fix that. All right, now that we have that fixed, let's go ahead and put that in our calculator. And we want Desmos. We want scientific calculator. So 174.86 parentheses 0.99 to 60. Which let's round to a whole number, 96. So the temperature of Carolina's tea after an hour will be 96 degrees Fahrenheit. All right, let's take a look at number 4. Use the equation to predict the temperature of Carolina's tea after 4 hours. Remember, 4 hours is equal to 240 minutes. Okay, so let's go ahead and do that. So same equation, except for we're going to change 60 to 240. And let's round that to 16 degrees. So the temperature of Carolina's tea after 4 hours will be 16 degrees Fahrenheit. 5. Does your prediction make sense in terms of this problem situation? Explain your reasoning. No, the prediction does not make sense because the tea will never reach 9.5 degrees Fahrenheit, a temperature below freezing in a room at room temperature. All right, let's take a look at the next page. Activity 5.3. Determine the best fit to model data. One measure of climate change is the amount of carbon dioxide in the Earth's atmosphere. The table shows the carbon dioxide concentration in Earth's atmosphere in parts per million from 1860 to 2017. Create a scatter plot using 1860 as year 0 in Desmos. So this would be 0. This would be 20. This would be 40. This would be 60. All right, let's go ahead and go to Desmos. Add table. All right, now again, you don't see the points. We need to adjust our window. Let's go from 0 to 200 is probably good. And 0 to looks like 500. All right, we're going to zoom out so we see the points better. Use Desmos to choose the correct function to model this data. Write your regression equation to find the variable, identify the correlation coefficient. X is the number of years passed since 1860. F of x equals the carbon dioxide cancellation. All right. This curve looks exponential, so let's try exponential first. Oh. All right. So f of x equals now we're gonna have to round 3 decimal places because we have 002. Okay. Okay. So our equation is 269.398 parentheses 1.002 to the x, and r equals, r squared equals 0.90. Sketch the function on the same graph as its scatterplot in Desmos, which we did. All right, let's take a look at the next page. All right, go ahead and mark out this page. Go ahead and mark out this page. All right, talk the talk. The student works 1A and 2A. Let's take a look at the next page. All right, go mark this small portion out. The student works 1A, 1B, 1C, 1D, and 1E. The student works 1, 2, 3, and 4. All right, go and start working on your assignment and have a wonderful Wildcat day.